This commentary on a few slides properly belongs to the topic we discussed in week 2, i.e. topic 2, in computer architecture. So what I'd like to do in this is to illustrate the fetch, decode, execute cycle with reference to the diagram I did actually show you briefly in topic 2. And the diagram I'm starting off with is a blown up view of the controller showing the presence of two registers, one that we've actually spoken about already. It's the program counter, it's the PC counter, whose role is to hold the value of the next memory address which holds the instruction to be executed next. And this register I've mentioned very, very briefly. It's the instruction register. And this holds the opcode part of the instruction when an instruction has been fetched from main memory. And I'm actually explicitly showing the memory data register and the memory address register. So the key idea is that the address register will hold the memory address for whichever location in memory needs to be read or written to. If it's a case of addressing the memory in order to do a read, then the data in the form of perhaps numerical data or the next instruction will be placed in the data register here. So I'm just going to take you through the main steps to illustrate the fetching of an instruction. So we could just consider the following instruction, which has the form move address. So in other words, move is an opcode and address will be, I don't know, an 8-bit address or a 16-bit address or whatever. And the meaning of this is to move the data to be found at this address into the CPU module's accumulator. So supposing this instruction is actually stored in memory at location memlock. So the key question is, how is it fetched from main memory? Let's see the operation of the CPU module in action. So step 1 is that it's marked by A here. You remember this is the address register. And the controller is actually going to move the address of the next instruction, which is held in PC, into the address register. And then the controller, this unit here, is actually going to issue a control signal to the main memory saying do a read. A short time afterwards, the main memory will actually have performed the memory read, and whatever is contained in the location which is being placed in A will actually be output into the memory data register. Okay, so that's simple enough. Let's just move on a little bit. So the address, as we've just seen, of the next instruction to be executed is held in the PC register and so on. And yeah, okay, so I've covered all that. When the instruction which is being fetched from memory is placed into the memory data register, the controller knows how to route what in effect is the memory address part of the instruction just fetched and now in MBR. So we can have a look at one below in a moment. And the address of the data in memory goes into the address register once again. So we'll see point 2 in the diagram below. And the controller will route the opcode part of what's just been fetched from memory and is now in the memory data register, and we'll route it in the form of binary digits into the instruction register. So we'll see that in the third point in the diagram below. And the instruction register, which informs the controller what to do, namely, in this case, is to fetch data from the address currently in the MAR and move the data found there once the memory has been read into the ALU's accumulator register. So let's have a little look at that. So what we've got at the moment, what we've got in the memory data register is an instruction. It was the next instruction to be executed. So two parts of what's in this register are separated into, first of all, the opcode part of the instruction, which is going to be sent into the instruction register. So that's in 3, right? And the address part of the instruction is going to be output and routed back into the address register. And if you remember, the illustrative instruction that we're currently looking at is, say, move the data from a particular memory address into the accumulator. So let's just check this out. So, okay, so the particular operation represented by the opcode is contained in the instruction register. The address register contains the address part of the instruction. And so what the controller is now going to do is to say, okay, well, let's fetch the data required. So using the address here, the controller is actually going to tell the main memory to do a read, and the number at the particular memory location specified is going to be placed in the data register. And the controller, using its various control signals, which are parts, as you will recall, of the control bus, is going to move the data along this bus into the accumulator. And at that point, the controller is going to think about, well, okay, let's move on to let's fetch the next instruction contained in the program counter. Let's resume the fetch, decode, execute cycle. So just one more diagram, which I think is just sort of duplicating what I've already said. I think it is, and perhaps there's no need for this diagram. Anyway, hopefully you'll find this short video helpful and explanatory of this rather mysterious phrase, fetch, execute, instruction. And it does require an understanding of the various steps needed by the controller and what happens to the controller as well, in terms of the PC counter being used to get the next instruction out, pull it out when it's told the main memory to read into the memory data register, and then separates it into the address parts of the instruction just fetched and the actual opcode part of the instruction, and put it into the instruction register. And once the opcode's been put into the opcode register, the control circuits can determine which signals are needed to bring about the conclusion of the operation. So, for example, the last instruction that we looked at was to actually move a number stored in main memory into the accumulator. Well, these control lines are going to release the data on this bus and make sure that the accumulator does actually remember it. It's going to send a signal to the accumulator saying, look, just remember what number you've just been given in the accumulator. Okay, so that's all. And thanks for listening.